Hello and welcome to video 2 on the Intro to SAS on AU Apps. In this video, we're going to talk about how to create new variables and recode existing variables, how to create a dummy variable, how to create some basic graphs, and run an independent samples t-test. So I'll switch back over to our SAS program that we were running before. We did some descriptive statistics and imported data. And now what we're going to do is we're going to recode. Now, most of the times we're interested in how percentages change in one variable affect another variable. In those cases, sometimes we would take the log of that variable. We're now going to generate the log of GDP/PC, the log of GDP per capita, which can be done in the data step. So what we can do then is we're going to say, okay, what's the data set? We're setting the data, and we're going to create a new variable called log_GDP/PC, which is a function of taking the log of our GDP/PC variable. If I highlight and run those lines of code, and if I click over at our log, now I have 14 variables rather than our previous 13. So if I scroll up, yeah, so we now have a new variable. What we can do then is we can take the descriptives for the log GDP/PC and see what that looks like. And now we have the descriptive statistics for a log of GDP/PC. We can also create a frequency table. So creating a frequency table of a continuous variable is not really all that useful. If you want to create a frequency table, we should recode that and then look at the categories. But let's say that we want to look at the frequency table for corruption just as an example. So to highlight and run proc frequency, say what the data set is. We want a table for the variable corruption. So again, not all that useful because it is a continuous variable. However, for binary variables or categorical variables, like whether or not a country is an OECD member or not, if we run this code on the OECD variable, this is actually quite meaningful. We have the frequencies and the percentages for how many countries are an OECD member and how many are not. Looking back at our corruption one, let's say we wanted to group these rather than a continuous variable into high, medium, and low for interpretation purposes. Now, this is quite common. This is also potentially problematic too because you lose variability. Essentially, all the countries within that low category, we're saying they are considered just a low. It doesn't matter within that low box of where they are. So they could be a 0.1, they could be a 3, they could be a 2.1 for corruption. We're saying treat them as equal for corruption scores. So you lose some nuances there. What we're going to do now is we're going to create 3 mutually exclusive bins that are non-overlapping. So when at first we have to set our data set, and we're using some if-else logic. So if corruption is greater or equal to 0 and corrupt is less than 3.3, then we're creating a new variable called corrupt categ, give them a 1. If else, if they're greater or equal to 3.3 and less than 6.6, then in corruption 2 corruption categ, give them a 2. And then if they're equal to or greater than 6.6, but less or than or equal to 10, in corruption categ, give them a 3. We're providing a variable label saying corruption index in 3 categories and running that. Then we're going to go ahead and apply value labels. So if they're 1, call that a high. Actually, yes, because we have not reverse coded this item yet. So lower scores actually mean higher corruption, medium, and low. So let's go ahead and we're going to highlight all of that. We're going to run it. And then we can apply that formatting to the variable. Because we created a format placeholder, and now we're applying that to our data set. Alternatively, this is another way you can do the same thing. It's a little bit more concise for programming. Does the same exact thing. And now what we're going to do is we're going to run a table for corruption categ and see what that looks like. So these are the countries of high, medium, and low. A lot more interpretable compared to this. Now what we can also do is I'm going to go ahead and take a combination of corruption categ in here as a frequency table. So for high, medium, and low, you can see on this diagonal, we only have those countries, so we don't have any misclassifications. Ones that should be in high but in medium, things that should be low but should be in medium. Everything is on that diagonal, so that looks perfect. And then if you wanted to remove formatting, you can use this. And finally, it's quite common to then actually transform categorical variables into dummy variables. So what we can actually do is we can actually dummy code out the corruption categ and dummy code it that way. So you can actually look at differences being in one of the categories compared to the other categories. So I'm going to go ahead and dummy code this out. And there's two different ways you can do that. Oops, went a little bit too far down. And I'm going to go ahead and run a proc frequency. So now I can actually see in corruption categ 1, that's a dummy coded corruption categ. We have 1, and if they're a 2 or a 3, they're a 0. You have corruption categ 2. If they're a 2, everything else is 0, and they get a 1 for being a 2. And if they're corruption category 3, they get a 1, everyone else gets a 0. And if you look here at the frequencies, they match the diagonals. So that all looks good. Now we're going to go ahead and create some basic graphs. So we're going to use create a histogram to show the frequency distributions for variable. Let's go ahead and create a histogram of the original variable and then log transformed one for GDPPC. First, I'm going to go ahead and show you some of the different options we have here. So we're looking at our GDPPC and then going ahead and comparing that with, let's see, there we go. So we've overlaid different curves, a log normal, a Weeble, and a gamma distribution. This is our distribution on the raw GDPPC variables. Okay, which one makes the most sense with this? We have our different thresholds, goodness of fit tests, and then if this is going to be for a fitted log normal distribution, if we're assuming the distribution is a Weeble distribution, how does that fit? And then finally, for a gamma distribution, how well does the data fit a gamma distribution? We can also go ahead and we can overlay the var GDPPC and log. So go ahead and run that. So we have the distribution of GDPPC with our different information here, the median, mode, standard deviation. And we also have the same thing for the log. Okay. Now, suppose that you're curious about the relationship between the daily log of GDPPC per capita and corruption categ. Now let's create a scatter plot to visualize the relation between these two variables. We'll include a trend line or a regression line in the title of the graph to help us understand what we're seeing. So first we're going to go ahead and we're using a proc gplot, saying the data frame name. And now we're defining the characteristics. We're saying label axis for axis 1. Our x-axis is going to be corruption. Our axis 2 is going to be log of GDPPC. We're going to angle that 90 degrees. We're going to add some information here for the dots. And then saying that we plot GDPPC over corruption, and then the axes, and giving it a title. So I'm going to go ahead and highlight and run this. And so now we can see higher scores on the corruption measure, which actually means lower corruption, have an associated higher level of log GDPPC. So there is a relationship. Remember though, corruption, higher scores mean lower perceived corruption. That's going to be really, really important for interpretations. Okay, we also have a t-test before I conclude. So a t-test is the most basic way to compare two groups based on the scores of a single variable. So we did create a corruption index based on 3 groups, but we can only compare 2 of those 3 groups when using a t-test. So what we actually do is we're going to compare the most corrupt with the least corrupt countries. So to do that, we're going to use a procedure. It's going to be t-test. We have to specify our data set name. Our class, that's going to be our grouping variable, corruption categ. Our var, that's our outcome variable. And then we're saying where corruption categ is not equal to 2, tilde equals. That's going to compare groups 1 and group 3. So group 1 is high, group 3 is your low, and we're giving it a title. So let's go ahead and let's see what that looks like. So we have our descriptive statistics for group 1 and group 3. We have our diff pooled or south away for correction. Now, given the equality of variances, this is assuming the variability of group 1 is roughly the same as the variability of group 2. If we reject the null, that there is no significant differences in the variability of these, if we reject that, that means that they're really not really comparable, so we have to use a correction. So when this happens, since it's below 0.050, we reject the equality of the variances assumption. So then we need to interpret the correction. We'll interpret the Souther weight, in which variances are unequal. We have 94 degrees of freedom. Our t-value is 21.33, and the p-value is less than 0.050. This means that there are significant differences, that we can reject the null hypothesis of the mean of group 3 equals the mean of group 1. Here's a visual of the distributions. And here's actually a bar chart to kind of show where the mean is, the median, the distribution of group 1 compared to that of group 3. So based on that, we can tell that the p-value tells the probability that of the result given the null is true. P-values do not tell you whether the result was based on random chance or reproducibility of the result, nor does it tell you the size of the effect. Now, in general, you're looking for a probability value less than 0.050. This is going to end this video, video 2. We'll pick back up in video 3.